All right, so for question 8, here's our diagram. The diagonal BD measures blank units by the blank. So we're matching letters for each blank in the previous sentences, X and Y with the words that correctly fill in the corresponding blanks. So I'm asking myself a question since I noticed that this is a triangle. So is it a right triangle? So if the answer is yes, which it is because of angle DCB is 90 degrees, we can use the Pythagorean theorem to solve for missing side lengths. The thing that we have to have is we have to have 2 known side lengths. So we check. We have side length CB right here, which is 12, and we have side length DC right here, which is 9. So yes, we can do that. So now the Pythagorean theorem is a squared plus b squared is equal to c squared. Now, the only side length that has to be labeled every time this way is C. C represents the hypotenuse, and the hypotenuse is always across from the 90-degree angle. So the 90-degree angle is right there. Draw straight across from it. That means that this side length is the hypotenuse. So I'm labeling it C. This then could be A and this is B, or we could have it switched and this could be B and this could be A. Either one for A and B, that's okay. So I'm going to use substitution. A right here is represented by the measurement of 9. So we have 9 squared plus B is side length as 12 units. So that's 12 squared is equal to C's measurement is represented by X, so that's X squared. And now we're going to solve for our missing side length. If I notice this X, the missing variable, is by itself on this side of the equal sign. So I do not have to add or subtract anything across from the equal sign because there's nothing being added right here to it. The one thing I will notice is that it has a squared. So how do I undo a squared? Well, I use this, the squares opposite operation is square root. They both have the word square in them. So squared and square root, they're inverse operations. So when something is squared, we square root. So square root both sides. So then on this side I have square root of 9 squared plus 12 squared is equal to the square root of x squared. So now the square root of x squared, these two undo each other and I'm left with x. So then I have the square root of 9 squared plus 12 squared. And actually when I introduced the square root, I should have written plus or minus, because you can have a positive answer and a negative answer for the square root. So then I'm going to use our calculator. And I'm going to type in square root, parentheses, 9x to the y squared plus 12x to the y squared, close parentheses, close parentheses. Do the parentheses matter? Yes, because this is saying that we're adding 9 squared plus 12 squared first, and we're taking the square root of that whole thing. So that's going to equal 15. So we have a positive version and a negative version of 15 is equal to x. Now I'm going to ask myself, okay, I'm talking about a distance of a diagonal. Can the distance be negative? No. So x is the positive version of 15. So our distance is 15. So you're going to be looking for 15 for x. And what did we use? We used the Pythagorean theorem. So you're going to be looking for the Pythagorean theorem for the y. Hope that helps.